Hello everyone, welcome to AK Competitives. I'm Mallesh Koram, and in this lecture we are going to discuss the concept of magnification by a curved mirror. Okay, so in the last lecture we have completed the mirror equation, and this is going to be the continuation to that topic. So without wasting the time, let's get into the topic. Alright, so the next topic is magnification by a curved mirror. Okay, in that we are going to discuss the linear or lateral magnification. What do you exactly mean by linear or lateral magnification? So when I have a curved mirror like this, if I have a curved mirror, then I'll be having a principal axis. Okay, let us say this is the principal axis. So if this is the principal axis, then I can put the object like this, or I can put the object like this. If I keep it like this, then it is going to be perpendicular to the principal axis. Okay, this is the way how we are going to say about linear or lateral magnification. Okay, so the next one is going to be longitudinal or axial when you're going to put along the principal axis. That will come later. So first we'll discuss the linear or lateral magnification when you put the object in a perpendicular direction to the principal axis. Okay, so how you are going to define here? So the ratio of size of the image, like suppose if I keep the object like this, if this is the object, then somewhere like this image is going to be created. Then how you are going to understand about the ratio of size in the sense when you're going to take height of the object, when you're taking height of the image, that ratio. Okay, ratio of the size of the image to size of the object is called as lateral magnification. Okay, lateral or linear magnification. Then for understanding this, let us take a diagram here. So again, same kind of setup we are going to take, the same kind of concave mirror we are going to take, the principal axis, aperture and pole, all are clear. So let us take a candle as an object, so which is going to be having h0 height. Okay, h0 height is going to be the height of the object, that is the candle. We are going to take it as object AB, we are going to say that is going to be our object now. Okay, now to trace the image, what we usually do, we take out of 4 rays, we are going to take a set of rays. Any two we can consider. We are already familiar. One will take parallel to the principal axis, and another we are going to take what you can call it as incidenting at the pole. Okay, first the object is at u distance from the mirror. Okay, then next one, let us take the first ray which is moving parallel to the principal axis. After hitting, how it is going to move? It will move by passing through the principal focus after the reflection. This is how the ray is going to move. Okay, now here let us take the second ray even. Second ray is going to incident straight away at the pole. So when it is incidenting at the pole after reflection, at what angle it is going to incident, at the same angle it is going to be reflected. Okay, this is the way how we are going to consider the two rays. Then where these two reflected rays are intersecting, that point is going to be image point for the point from where you have taken these two rays on the object. Okay, now see the image now. Image is going to be inverted here, and it will be like as shown in the diagram. Okay, now here at what distance this is happening? At v distance it is happening. So now we will go to derivation also, but try to understand this particular diagram here. So to find out what is going to be the ratio of height of the image to height of the object, we need to consider two triangles. What are those? One is the blue shaded one, triangle ABP. Okay, another one is going to be triangle A-B-P. Okay, these are the two triangles what we are going to consider, and we are going to derive this particular phenomena. Okay, so let us keep this diagram on the other side, and then we'll try to derive this particular derivation for what is going to be lateral or linear magnification. Okay, now here first see the formula. So magnification is represented with M symbol, and this is going to be the size of the image by size of the object, and hi is going to be height of image, and h0 is going to be height of object, and that ratio we are going to take. And you are going to see here minus v by u, which is equal to f by f minus u, or f minus v by f. How we are going to get these? Okay, we'll try to derive it now by using mirror equation. Okay, now here first consider the two triangles here. So two triangles we are going to consider, as I told you already. So in the diagram, triangle ABP and triangle A-B-P. These are the two triangles what we are going to consider here. And then from these two triangles, write the equation for tan alpha. Tan alpha, how you are going to write it? Tan alpha is equal to AB divided by AP, and that is also equal to A-B- divided by A-P. Are you able to understand? And now from the diagram you substitute by using sign convention. What is this AB? What is this AP? And what is this A-B- and what is this A-P? Okay, all these we are going to substitute. Then h0 is going to be AP and minus u is going to be AP and minus hi, because the sign convention we are using properly. Above the principal axis, heights measured are going to be positive. Below the principal axis, heights measured are going to be negative. And obviously in the direction of incident ray, you are going to take positive. In the opposite direction, you are going to take negative. Okay, now here all the distances are measured from pole. Let us see here the continuation. Height of the image by height of the object, if you write from this particular equation, you are going to get minus v by u. Now use the mirror equation as I told you. 1 by u plus 1 by v is equal to 1 by f. Okay, so now just multiply with v on both sides to this particular equation. So this is the way how the equation can be transformed. Okay, in the similar way, if you are going to just eliminate v, you are going to get u by using the same equation. Okay, why these are important? Because in the step what I have given, minus v by u is enough actually speaking, because you will be able to given you will be having object distance, you will be having either of focal length or image distance. From there you will be able to easily find it out. But you have to calculate image distance if it is not given. So then here, if you remember that particular statement completely, whether they have given u and v, whether they have given u and f, whether they have given v and f, and we'll be able to find out what is going to be the magnification. Okay, so this is the clear idea how you're going to understand about linear magnification. So this is the final step how I am going to tell you here. So let us move to the next one. So longitudinal or axial magnification. I told you, right? So when you're going to keep the object, if this is the mirror along the principal axis, if you keep the object, how you are able to find this? Let us see now a diagram again. So but before diagram, as usual, we'll see the definition. When the object is kept along the principal axis, then what is going to be the ratio of size of image to size of the object? Basically, length of image to length of object is called as what you can call longitudinal or axial magnification. Okay, let's see the diagram. Same set of diagram I'm considering again here even. So now you can see clearly the principal axis and curved mirror, everything we have taken in detail, and object we are considering as a crocodile here. So which is going to have L0 is going to be the length. Okay, L0 is going to be the length of the object. So here which is going to be along the principal axis. Okay, along the principal axis you can see this. Now if you're going to see the distance of object is u, then here the image is going to be formed as shown in this. The image is going to be formed like this, where Li is going to be the image. Now the question comes, so object distance from which point you're going to take? So we are not so clear, because we can take from A or we can take from B. But here this case we have to divide into two parts. One is when the length of the object is going to be smaller compared to that object distance, then you can just take u is going to be from the center, somewhere from the center of the object you can consider, and we can be able to go with the formula what I am giving. If not, what we have to do I will tell you. Okay, so just see this. So image is formed at v distance, and now again, so keep this diagram on the corner and we'll try to move for derivation part. Okay, axial magnification we are going to define like this. So length of the image by length of the object, and delta v I have written because for two ends of the object there will be two ends of the image. So two image distances will be there, two object distances will be there. The difference of object distances will give you length of the object. Difference of length of the images will give you image length. Okay, so now this is the idea. And if length is going to be small, as I told you, so you can directly use this differentiation method, where I'm going to use 1 by u plus 1 by v is equal to 1 by f. Differentiate this with respect to u on both the sides. Then what you're going to get, so simplify like this, then straight away you're going to get what you can call it as dv by du we need to find, because dv you can write as delta v, du you can write as delta u, length of the image by length of the object, and that will be minus v square by u square, which is usually square of the longitudinal linear magnification. So longitudinal magnification is square of the linear or lateral magnification. Like that we can write. So now here the axial magnification is going to be basically given like this, and any set of formula you can use again from the previous derivation. If length of the object is going to be comparable, like 10 centimeters is the object distance and 1 centimeter or 2 centimeters is going to be the object length, then you cannot do this. So what you do, first end A you take UA, end B you take UB, then find on the image what is VA and what is VB, take the difference of object distances, length of the object. Take the distance of difference of image distances, length of the image. Then take the ratio, that will give you magnification. I hope all of you are able to understand this. So this is the idea of magnification, what we have to do. Okay, let us move to the next one, aerial magnification. What do you mean by aerial magnification? So when you keep a two-dimensional object, like a plane you're going to keep in front of a mirror, this is the mirror, you're going to keep the object like this, then how you're going to find the image? So same thing again, area you can keep in two ways. One is you can keep the area perpendicular to the principal axis. Suppose if this is principal axis, then you can keep it like this, or else you can keep it like this by facing one of the side is going to be coinciding with the, what you can call, one of the side is coinciding with the principal axis. Okay, but here we'll see the derivation when you're going to keep it perpendicular, and then we'll come back with the problem when you're going to keep such a way that one side is coinciding with the principal axis. Okay, let us see now the diagram again as usual. So just I am taking a two-dimensional object which is placed perpendicular to the principal axis. The image formation way is going to be same, there is nothing difference, and image is going to be formed. So now one point which you have to keep in mind here, so when image is formed, suppose if this is the principal axis and if object is above only, if the object is above only, then image will come below only. That is the first point what you have to keep in mind. If the object is outside in the sense you can see it is outside, then image will go inside, like side of the principal axis will be changed. Like if it is already inside, it will come out. If it is already outside, then it will go in. If it is above, it will come below. If it is below, it will come above. So again, so based on object distance, this case will also change. So in one of the video, we are going to see for the different object positions where the image is going to be formed. Okay, I'll tell you that, there you can get a clarity. But for this given situation, it looks like this, and this is how we are going to trace the image. So again, ratio of the image to ratio of the object areas is going to be called as aerial magnification, and this is the way how we are going to find it. And here, so for as it is perpendicular, for both length of the object and breadth of the object, you can use the same lateral magnification formula and take the product of that, it is going to give you aerial magnification. Okay, so this is the idea. Let's move to the problems. So first problem which is given, there is an object so which is going to have 1 centimeter length, and then it is placed at 15 centimeters from the pole of the mirror of a concave mirror which is having focal length of 10 centimeters. Then they are asking you to find out size of the image, and also they are going to ask you what type of image is going to be formed, like whether it is going to be diminished or whether it is going to be enlarged or whether it is going to be inverted or erected. All this kind of nature they are going to ask you. Okay, so let us try to find, and magnification also they are going to ask you in this particular problem. First, what is the given information? They have provided you in the problem first height of the object, and second what they have given, focal length and object distance, and they are asking you image distance, and they are asking you magnification, they are asking you nature of the image. So first you need to identify what is given, what is asking, what is the relation. Mirror equation is there and magnification formula is there, so we can be able to find out. Now through magnification formula I will tell you first. So what is going to be the U value? U value is minus 15 centimeters. What is the F? F is minus 10 centimeters. So now magnification M is equal to F by F minus U. Magnification is F by F minus U. Already we have discussed the formula, and here it is kept perpendicular. You have to consider, they have not mentioned it is along the length. So now here, so here what is going to be F? F is going to be minus 10 divided by, what is going to be the object distance? 15 actually. So minus 10, minus of minus plus 15. So what is going to become? Minus 10 divided by 5, which is minus 2. Okay, magnification will be minus 2. Now, second part of the problem. So now what is going to be the height of the image? Height of the image is by height of the object, which is going to be M, right? So magnification is height of the image by height of the object. Then here if I am going to write height of the image, which is equal to this height of the object to take on the other side, magnification is minus 2 multiplied by height of the object is 1 centimeter. Then height of the image will be minus 2 centimeters. So here negative magnification tells you it is going to be inverted, and as it is greater than 1, so it is magnified, and What is going to be the image distance? You can find by using mirror equation 1 by v plus 1 by u, which is equal to 1 by f. Now here, what is going to be v? Unknown. And one more important point, don't put any sign for unknowns. Unknowns, you have to leave it as it is when you do the problems. Okay, so now here plus 1 by minus 15 is equal to 1 by minus 10. Now what you can get? V is equal to minus 30 centimeters. Okay, this is how, and from this also you can be able to get what you can call it as magnification, and you can take v by u, minus v by u, again you will get the magnification formula. Okay, so this is the answer, how you have to know it. Okay, so let us move to the next question and we'll try to understand one more concept based problem. Okay, here it is going to be based on aerial magnification. Now here, if I give you a question like this, there is a square of side 1 centimeter which is kept perpendicular to the principal axis. If this is the principal axis, then it is going to be perpendicular. Now here at what distance you have kept, and at a distance of 30 centimeters from the mirror of focal length 20 centimeters. Then find the area of the image. Okay, that is what they asked you question. Quickly see the diagram how it is going to be done here. So object of side 1 centimeter, it is a square, basically area will be 1 centimeter square for object. Now here at what distance? 30 centimeters you are keeping, and now here take trace the image. Now image is as usual, like any point, for each and every point on the object you will be having one point on the image, and you are going to trace the image somewhat like this, where it is going to be formed. You can find again same kind of derivation you can utilize. See here, 1 by v plus 1 by minus u. Directly I am putting the value. U value is 30, so that minus 30 here, which is equal to 1 by minus 20. How much you will get? 1 by v, which is equal to 1 by 30 minus 1 by 20. Okay, so if I'm not wrong, you will get 60 here. So just you can calculate this, 1 by v, which is equal to 2 minus 3 by 60 centimeters. Okay, actually it is also not required for finding magnification. So we have to directly take from f and u also, we can be able to find out the magnification. What they're asking you, area of the image. So magnification m will be, what you can write, f by f minus u whole square. What is the f value here? M will be, f will be minus 20 plus 30, minus of minus 30 actually, whole square. So how much you'll get? Minus 20 divided by 10 whole square, which will get 4. Okay, aerial magnification will be 4. Okay, aerial magnification will be 4. Now what they are asking you, size of the image, right? Area of the image. Area of the image is equal to m area into area of the object. Okay, then find out area of the image, which is equal to 4 times of, what will be the area of the object? 1 centimeter square. So area of the image is 4 centimeters square. This is the idea how you're going to do it. And this is simply formula based questions, and you'll be able to get directly like this. And this is the way how we can understand. Let us see, I told you right, the second type of model, how we are going to do another kind of problem, like when one side of the image object is going to be coinciding with the principal axis. See, this is the question. So there is a object square of side f by 3, which is going to be kept in such a way that one side is going to be coinciding with the principal axis. And now here, so the diagram is like this, and how you're going to find out the image now. So for object, there are two ends, and f by 3 is not smaller, so that it is comparable. You have to take two object distances. So here for A and C is going to be one plane, and B and D is going to be another plane. For A point, so now what is going to be UA? UA is equal to 2f minus 2f. Then immediately if you're going to put this value into what you can call it as mirror equation, VA also you're going to get minus 2f. Then A dash C dash will be AC, which is f by 3. in magnitude and negative actually. So it will be just inverted and of same size image you're going to get this. So like this. But for B, UB, which is given as how much? 2f minus f by 3, right? 2f minus f by 3. How much you will get? Minus, so 5f by 3. Minus is because the sign convention I'm using. So usually 5f by 3. But when you use the sign convention, it will be minus 5f by 3. Then 1 by VB minus 1 by UB, which is equal to 1 by f. Because focal length is same for both the mirrors. If you put into this VB, you are going to get minus 5f by 2. Okay, then what is going to be the H2? H2 is going to be height for the edge B dash and D dash, which is going to be image of B and D. So now here H2 by f by 3, which is equal to, what I can write? Magnification. Magnification is nothing but what you can say, minus of VB. VB is how much? Minus 5f by 2 divided by minus 5f by 3. Okay. Now here H2 is equal to minus f by 3, 3 by 2. 3 gets cancelled. What is going to be H2? Minus f by 2. Then what is the area of the image? Area of the image is equal to, image you can see clearly it is like a trapezium. So what is the area formula? Half into H1 plus H2 multiplied by length of the image. What is the length of the image? 5f by 2 minus 5f by 3. Okay. So sorry, actually 5f by 2 is going to be VB. From there, what is going to be VA? VA is going to be 2f. So like that you can be able to find out. And this is the idea, half into H1. How much is H1 here? H1 will be f by 2, f by 3 plus f by 2. I am taking only the magnitudes. So multiplied by 5f, VB is how much? 5f by 2 minus 2f. 5f by 2 minus 2f. Now here half into, how much will be? 5f by 6, right? This is going to be 5f by 2 minus 2f. So f by, product by 2 you are going to get, because 5f minus 4f, which is going to be f by 2. How much it will be? Like area of image, which is going to be 5f square divided by 4 into 6, 24. 5f square by 24 is going to be the answer for area of the image. Then what is going to be the area of the object actually? So here you can see area of the object, which is going to be f square by 9. Take the ratio, magnification, there's nothing but ratio of area of image to area of the object. So if you take the ratio, then you're going to get the magnification value. Okay, so that's it. This is the topic for today's lecture. In the next lecture, we'll take another interesting topic and we are going to discuss the concept as well as the problems. As I promised you, in coming videos, I'm going to do some numerical sessions also for mains and advanced and NEET level separately. So I hope all of you like the video. If you like it, please like the video and share to others. And if you have not subscribed, please subscribe to the channel so that you can get all updates of my coming lecture. Thank you all.